Regardless of which protocol you're using, whether it's OSPF, EIGRP, or BGP, the ones and zeros part of route summarization is always the same. I'm always saying it's all ones and zeros, but it's really all ones and zeros when it comes to route summarization. You just got to write the routes out in binary. You identify the common bits, you add those bits up, you get your route, and you get your mask. It's just that simple. Now, this being BGP, there have to be a few minor differences as far as applying the route summarization, and we're going to see those in action live in this lab. I've set up a quick little IBGP adjacency between routers 1 and 5 and AS15, still over the 10110/24 network, and let's take a look at the routes being advertised right now. You see on router 1, we see a valid and best entry for networks 16, 17, 18, and 19, all with a 255.0.0.0 mask, and we know that because we don't see anything different here under network. We've got next hop 10.1.1.5. We certainly expect that. All the other values are at their defaults. We see everything we expect, and everything's good. Now, there's nothing wrong with this entry, but we love to keep our routing tables complete and concise. And it takes the same skill to summarize 4 routes as it does to summarize 8, to summarize 16, to summarize 32, to summarize more of them. It's a great skill to have for even more advanced Cisco exams, especially if you're looking at your IE down the road, but it's a fantastic skill to have for real-world networking as well. So here, what we want to do is replace these 4 entries with one summary. And we're going to do that first off by doing a little bit of work on the board, and we're going to come up with a summary route and mask. You may have already done that in your head. If you have, fantastic. If not, here's a quick review on how we do it. Common bits are highlighted here, and of course on paper you would likely just draw a line where the common bits end. But you want to write your routes out in binary, then just go from left to right, and when the common bits end, you have your route and your mask. You just have to add some bits up. Now, if we write 16, 17, 18, and 19 out, this is what it looks like. And there's no reason to write out the full address for all of these, because first off, the common bits are going to end in the first octet. We know that. We also know what 0 looks like in binary, right? 0, 0, 0, 0, 0, 0, 0, 0. There, you don't want to hear me say that continually, so we just need to break down the first octet. Going from left to right, we have 6 common bits, because the 7th bit in 16 and 17 is a 0. And the 7th bit in 18 and 19 is a 1. All we have to do now is add up the common bits, and that's going to give us our summary route. And here, the only bit that's even set in the common bits is the 16 bit. That's it. So we know the summary route is 16.0.0.0. Now, how do we get the mask? Because we've got to have a mask. And to do that, all you do is put a 1 in your mask for every common bit and a 0 for all the others. And again, no reason to write that entire mask out, but you know you put a 1 in the mask for every common bit, that's going to be the first 6 bits. 0 for everything else, we know what that gives us in dotted decimal, 252.0.0.0. So we're gold. We've almost got it done. We just need to introduce the route. And we do that with the aggregate address command. Let me swing over to 5 here. You always want to use this, of course, on the point of at the point of summarization. The router's actually doing it, and I know, duh, but I'm telling you anyway. So now let's use iOS help here and have a bit of a look around. Note that aggregate address is a command onto itself. We've used a lot of neighbor commands here, and it's easy to get in the habit of just putting neighbor, 10.1.1.1, and then using iOS help and saying, okay, where's the aggregate address command? This is a command onto itself. So we will use it that way. And the first thing it's going to ask us for is the aggregate address itself. And you know what's coming next, that mask. And we got some options here, and most of these you haven't seen yet. And it's interesting, on top of the route map, which we have used, we see an advertised map, we see an attribute map, we see a suppress map. We're going to save those for future studies. That's not part of the NP route. But I also see a CR at the bottom, and that's definitely a part of the NP route exam, because that means, of course, this is a legal command by itself. So let's go ahead and enter that, and we'll see what happens. Let's see if our change has gone over that quickly. Oh, this is kind of interesting. We have the summarized route, and we see it 16.0.0.0/6, but we also see the individual routes. We see the routes that have been summarized. So maybe BGP just hasn't finished cooking yet, so to speak. Maybe it's going to update itself. No, it doesn't look that way. Let's go ahead and do a clear. And let's run show IP BGP again. And it looks like those individual routes are not going away. And the reason they're not going away is that this is actually the default behavior of BGP. When you use the aggregate address command with no options, you're going to advertise the aggregate and the individual routes that have been summarized. Pretty interesting default there. Let's go back to router 5 and have a look at that aggregate address command again. First off, I'm going to take that off, and then we will go back and look at the options. And I said, that wasn't a cheat. I was saying that a couple of these we weren't going to use yet, the advertise and attribute and suppress maps in particular. Route map we've used. This isn't really an AS set, AS path deal. So what about that summary only? See, if you were really particularly eagle-eyed, you probably noticed that suppress map, if you look at the iOS help description, conditionally filter more specific routes from updates. Well, if you see that, especially if this is the first time you've seen it, you might think, well, why am I needing to filter more specific routes from the updates? Aren't they already filtered? Well, now we know that they're not. So while we're not using a suppress map in this course, it's a good idea to know that if you run into a situation where you need to filter some of these individual routes, but not all of them, you can use a suppress map. It works a lot like a route map. What we're going to do, though, is filter all of the more specific routes. And we're going to use summary only to do that. Now let's hop over to router 1 and see what we see. And look at that already. The change has taken place and those individual routes are now gone. So again, nothing complicated here. You've done this a million times as far as the actual route summarization goes. If you haven't done it for a while, practice it a little bit. It becomes second nature to you again. The key is remembering that with BGP, unlike all the other protocols we've used, the more specific routes are going to be advertised by default along with that summary, and now you know how to get rid of those individual routes. Coming up next, a lot. We're going to talk about full meshes. We got some route reflectors on the way. We've got the rule of synchronization on the way, and that's all coming up in the next couple of videos. I'll see you there.